Hello, everyone. My name is Terry Wilk, and I am a principal with Stantec. I chair the Research Grant Committee for the Education and Research Council of the CISC. Each year, we receive grant applications from colleges and universities across Canada for research into structural steel. We look to annually award up to $100,000 in grant support for these colleges researching structural steel. The principal researcher of the top vote getter amongst the submissions is awarded the H.A. Krentz Award and $5,000. The H.A. Krentz Award is named for Hugh Krentz, who was instrumental in developing codes and standards, was an educator and a mentor to the Canadian steel industry. I am very happy to announce that in 2020, the winner of the H.A. Krentz Award is Professor Robert Driver from the University of Alberta and his research project dealing with artificial intelligence applications to the Canadian steel industry. Congratulations, Bob.
Well, thank you very much, Terry. It's a pleasure for me to be able to accept this award on behalf of our research team. And thanks to your committee for seeing value in our proposal. We're very much thinking of this as a future-focused research project, and it was really a result of it being quite apparent that design itself is changing, and it's time to really have a look at whether the steel industry can maybe leverage some of the advanced technologies that are out there to become more efficient and have better steel structure designs. So this is part of the emerging technology stream at the Steel Center. We're looking at a variety of different projects, but before I get started on describing a little bit about our project, I'd like to just acknowledge our team, and particularly my colleagues Ali Emanpour and AJ Daras, who are helping to lead this research stream. And we're very lucky, of course, to have some talented and enthusiastic students who are carrying this research program forward. So the project that we proposed is largely an exploration of advanced tools. So we decided to take a look at some of the things that are part of the day-to-day life of any steel fabricator. And these things would be cutting, inventory management, materials management, and movement, and connection design. And these are things that are not independent decisions about the design. There's input from a variety of different locations in the design process. So what this is largely an optimization project. So one of the trickiest parts of that is to define what optimization actually means. So these things can have impact that are interrelated, and there requires input as well from architectural decisions, owner decisions, and so on. But we're going to focus on cutting, inventory management, and connection design. So I'd like to present a little video that one of our students has prepared to just give a flavor of what this research project is about. And this one happens to be related to connection design, steel connection, or shear connection design. And within the software, the user has the ability to pick a number of different parameters, specify parameters, put limits on parameters, and also provide optimization criteria and put weightings on the optimization criteria. So the model is created in the software. It's fully parametric. So all of these things can be changed according to the project criteria. And within the software, designs are done. So the code checking is done. We've done it with spreadsheets. We've done it with coding within the software itself. And we've also done it with component-based finite element, specialized software program for connection design. And I think this is probably going to be important for going forward because as we get to connections that are more complex, we may not have conventional design processes. So the final thing that is shown in this video is the optimization part. And this is taking competing optimization criteria with their weightings, and the common analogy is genetic. So it's like certain genes are meeting the criteria and they are able to go into the next generation, and other ones come to the end of their lineage. So it's somewhat like a Darwinian survival of the fittest approach. And at the end, we have not just a single design, but perhaps a suite of designs from which the designer can select an appropriate solution. So I think what a lot of people see in this is speed, but I don't think this is the main benefit of the research that we're doing. I think what's important is that we may be able to come up with innovative solutions that perhaps wouldn't have been considered by a designer based on biases, based on the way things have been done in the past. And over the next number of years, we may find that that artificial intelligence is able to allow the steel industry to come up with some new solutions that perhaps don't even exist today. And we're really excited about it and looking forward to sharing the results with CISC and the CISC community in the coming weeks and months.
Thank you, Bob. We're looking forward to hearing about your research as the years progress, and we look forward to your continued submissions to the CISC. Thanks again.